Hey everybody, this is Mr. Longo, and in this video we are going to cover exponential functions and their graphs. So remember, a parent function is a function that has no transformations done to it, and a basic exponential function is just y is equal to n raised to the x power, where n is any number. So I want to think about a couple of things before. Think about 2. Let's do 2 raised to the 0 power. Remember, anything raised to 0 is 1. And then, of course, 2 raised to the first power, or any number raised to its first power, is itself. Of course, 2 squared, we know, is equal to 4, which means it's going to grow exponentially. Next, 2 to the third is 8. But what if you have 2 to a negative number? Let's do 2 to the negative 1. That does not make it negative. That just means reciprocal. So it becomes 1 over 2, or 1/2. So it's important to know that you cannot take a number that's already positive, raise it to an exponent to make it negative. That's going to help explain something in a second called the horizontal asymptote. So if you think about a function, numbers raised to any number are just going to exponentially get bigger and bigger and bigger really, really fast. But any number raised to 0 will always be 1, and any number raised to a negative will just make it smaller and smaller and smaller in terms of a fraction. 2 to the negative 3 would be 1/8, so it's still a fraction. It's just going to get smaller and smaller. So they will never become negative, which is why your horizontal asymptote is going to be y equals 0 for the parent function. And that's why you can never raise a number to get a negative. You can only multiply. The point, 0, 1, is because we just said any number raised to 0 will always be 1. So in your parent function, 0, 1 will always be a point. So if we think about domain, you can plug in negatives, you can plug in 0, you can plug in positives. Your domain for exponential functions is going to be all real numbers, but your range is from 0, not including 0, to infinity, because it's just going to go up forever. Now, of course, that is unless we decide to put a transformation on it that flips it over the x-axis. Until then, that's your pretty much general rule of thumb. So let's go do a couple examples where we work with transformations. So remember, we work with the inside first, and that is your negative x. So your first transformation for this example, e to the negative x plus 1, your first is reflect over the y-axis. And your second transformation is up 1. So what that is going to do is it will shift your horizontal asymptote up 1, so it's going to be y is equal to 1 now. And it's going to shift your point up 1. So remember, our point was always going to be 0, 1, but now we just shifted it up 1. Reflecting over the y-axis doesn't change it at all, because it's 0, 1, reflect, it's still 0, 1. Going up 1, however, will make this point 0, 2. So we're going to have 0, 2 right there. And we just graph both of our transformations. We're done. So the graph is now going to look like this. And our domain and range are going to be very similar. Your domain is going to be x is equal to all real numbers. But your range is going to follow your horizontal asymptote. So it's going to be y is greater than 1 now because we shifted that horizontal asymptote up. Okay? And that's it. It's really not too bad. So let's go look at the second example. There are a couple of different transformations, and we'll just follow the rules and we'll be good to go. So start inside. That's your x minus 3. So your first transformation is to go right 3. And your second transformation, we jump back outside, work left to right again, is to vertically expand by 3, or vertically stretch by 3. So First thing you want to think about is your horizontal asymptote. Did it go up at all? Nope, it did not go up or down. So your horizontal asymptote stays the same. So y is equal to 0. Y is going to have something to do with 0. We're not going to talk about that yet, just in case, and I'll explain why. So we're going to go like this. Next, our point. This is a little bit different. Remember, we started at 0, 1. We went right 3 first. So that went to the right, which is x3, comma 1. And now we vertically expanded, which remember we multiplied the y by 3 there. So 1 times 3 is 3. Our new point is actually 3, 3. So we're going to go to the right 3, and we're going to go up 3, and this is where our new point is going to be. And then we're just going to draw our sketch. Something like that. Domain, still all real numbers. The reason why I wanted to wait on the range is it's still going to follow y is greater than 0. But I wanted to make sure we talked about the different transformations. If we would have reflected over the x-axis, that would have made it go down. It would be below 0. Okay, so usually with range, you want to wait till you see the graph before you make your final call. Okay, and that's it for this video on exponential graphs. This is Longo, and I'm out. See you, bye.